unmute myself so I can actually show you guys. Thank you. I'm excited to follow up with this, and I wanted to show you a little bit of what I've been looking at here in Oregon. You know, and so we've talked a little bit about Globe Observer land cover and photos, and I wanted to highlight an area that I know burned recently, and I wanted to just kind of show you a little bit of how I put together and some ways that you can actually use the Open Altimetry website to possibly look at an area that you care about. In my case, I'm zooming into an area here in Oregon, in the United States on the western coast. And one thing that I did notice as I zoom in, there was an area that I went through and actually looked at because it had burned previously. And so when we talk about burned landscapes, what we're actually seeing on the ground is things like this. In this case, there was actually snow on the ground. And if I blow up this picture, we can actually see standing dead trees that are here as a result of this fire that happened in 2010. And what was really interesting is that, let me move that down, is that when I go to the Open Altimetry website, there happened to be an area here, just in that same area where I did those measurements, right in here, where you can actually see there was green trees that were out there, or green areas in the satellite imagery. But then there is this kind of brown area that has an interesting shape to it. And that is the fire that happened in 2010 on the northern side of Mount Hood. And Mount Hood is one of these big volcanoes that has about 7,000 feet elevation rise. And so using the Open Altimetry website, I went in and I used the select region tool and just drew a box over an area where we can see the LiDAR measurements that came up. And so what that did is it actually opened up the beams and the LiDAR measurements that we were just hearing about. And what was interesting for me when I was looking at this, when I look at the photon heights, so this is the reflected light, and here we're talking about green light. So it's important to think about vegetation reflect that green light. And that's one reason why we see it as green. And so our eyes are doing remote sensing like that. And so one thing that really popped out that I thought was interesting is we kind of have the shape of the mountain. And this is, if we notice, here's the very top of the mountain on the left-hand side of those signals. And that's actually the white ice-colored top of the glacier of the mountain here. And then as we go down, one of the things that's interesting to note is we have these photons that cluster around at this 2,500 elevation all the way across, while we have the slope of the mountain actually go down. And so we actually recorded clouds in this. It's the only explanation I can think of why there would be this cluster of clouds at this location and this location. Just so very, very interesting the way that not only are we able to measure the ground with LiDAR, with these laser beams, but we actually are getting something about the atmosphere. So I just thought that was really interesting. And at first, looking at this, I just kind of see some blue lines. But if I actually go in here and zoom in just by dragging this, all of a sudden I can actually see that point cloud that we were hearing about earlier. And I can zoom in a little bit more, and what we see is the surface model where we get a lot of strong returns coming back. But then you can also see the top of the trees. So those were the trees that I was actually just showing you here. We were actually getting the LiDAR returns from some of the standing dead trees and everything. So this is why it's important for you to go out and actually make some of these measurements on the ground, so we have that reference data to understand, is this really cloud or is it vegetation on the ground? And there was a great question about whether we can use this to identify different types of vegetation. And in fact, we can. In this area right here at the top, we actually see where we have kind of an even height of trees there. And that's a great way that we can tell that these are all living or about the same size, where this big gap that we have less dense trees is an area that you can then go out and explore when we're not under a public health crisis. So I wanted to highlight this as a way of taking what we've been talking about and even being able to look at it yourself, because this is one of the first data sets that allows us to look at LiDAR data and compare it to your location globally. And so that was a little bit of my exploration. And so as a result of that, it really got me kind of thinking about the data that has been coming in across all of our projects. And since we don't actually have LiDAR data around the world, what we actually do have is high resolution satellite imagery or imagery. And so I've set up this project for us to explore together, to look at some of these locations. And so we'll include this and do a little bit more of detail about how we can use this high resolution imagery to actually go in and look at data together. And so there is this tool called Collect Earth Online. And this actually allows us to go in, and if you look up the GLOBE program, and we have this project called Globe Trees. And when you go to that, what will pop up is you can see where all of the data coming in is located. And since I'm actually showing this live, some of the menus aren't popping up. But you can actually start zooming in, and you can start to see where we start getting the data that's coming in from around the world. And so zooming in on some of the data that we've had, we can actually use this high resolution images to start understanding what we're seeing in these landscapes. And so you can actually see this area right up here that I was showing you. We will have some areas where I went out and made some measurements right in this location. And the point is, you know, we can actually see this and be able to compare our ground, this high resolution imagery to what we're actually seeing when we look at this from space. So we'll set up another webinar to actually describe how you can be part of describing some of these landscapes with the high resolution imagery, which really complements the laser measurements, because using these two things together is how we take these point measurements that come across with the LiDAR data, but then use the optical data that gives us what we call wall-to-wall coverage to be able to create a global height map of vegetation, whether it be trees or whether it be tall shrubs. So since our webinar is coming to a close here, I don't want to go through and throw a whole nother tool at you, but just I wanted to let you know that we will be developing this so that since we can't go outside and make measurements, there's another way that we can actually go back and look at our data and even find errors like what Brian was highlighting earlier about palm trees in northern Siberia. So I look forward to following up and sharing this again with you guys, and seeing how we can actually look at our data and do some quality analysis with it. But since we've been talking LiDAR today, it's really a good time to go and explore this open altimetry tool and see what kind of laser beams and laser measurements were made around your location. And then use the Globe Observer tool or use the Globe visualization tool to see what kind of trees have been measured, and start thinking about where you might want to go make some measurements later on when we're not under a public health crisis. So I appreciate you guys learning all about LiDAR. It's a really neat way to start thinking about not just spatially where things are located, but structurally what's around us, and starting to think about how tall the landscape is. So with that, I'm going to stop sharing.